Welcome to the 4.2 next video. We are going to learn how to do polynomial division today. So, dividing polynomials is the opposite of multiplying and can be done by reversing the box method. To review, we're going to go over the box method over here, and then I'm going to show you how this would work backwards on the right. So, when we want to multiply these two things, what we do is we write them both um, like this. One of them goes along the side and one of them goes along the top. Does not matter which one goes where. And then we draw this in a little box and we can multiply these two things. Now, you don't have to do this with this problem. I mainly told you guys to do this when there was three terms. The reason why I'm doing it anyway is so that we can reverse it over there on the right. And this one's a little bit easier. It'll make more sense. So then each little box in here gets these two multiplied to make this one, these two multiplied get this one, and so on. So this will be 6x squared, 3x times 4 is 12x, 2x times negative 5 is negative 10x, and negative 5 times 4 is negative 20. And then at the very end, what we do is we add our like terms here in the middle. So then we have our 6x squared out front, and then this adds up to 12 minus 10, and then the negative 20 stays at the end. What's going to happen on this side is we are going to start with the pieces in the middle and work to the outside. Okay, so this is actually the exact same problem. 6x squared plus 2x minus 20, and then two mistakes actually. That little squared isn't supposed to be there, and this is supposed to be a 4. Okay, so change the 2x plus 5 to 2x plus 4 for me. What we're going to do is put the 2x plus 4 over to the side. And when we're reversing the box method, it's usually a good idea to put that part on the side, and I'll show you why in just a second. So then I'm going to draw my first column, and I don't know how many columns I'm going to need yet, so I'm not going to keep going. How you do reverse box method is you want to know what multiplies by this to equal this. That's really what you're doing when you divide. And I'm actually going to pause and come down here and do this part really quick. If you have something like A over B equals C, you're just dividing two things and your answer is C. This is the same thing as saying that whatever is on top equals the answer times what you were dividing by, because you could technically get rid of that b by multiplying it to the other side like that. Okay, I'm going to kind of cross those out now because I don't want that to confuse you. So a over b equals c is the same thing as a equals b times c. So really, we are just figuring out how many times this goes into this, which means it would get multiplied by the answer to equal that. And that's kind of the main thing we're trying to do with division. Here's a really easy example of that. When we do 12 divided by 4, we're really asking ourselves 4 times what equals 12? And that answer, of course, would then be 3, because 4 times 3 is 12. 12 divided by 4 is 3 because 4 times 3 is 12. So multiplication and division go hand in hand, they're just opposites. So what we want is for our answer to be right here on the top of the box, because this times this should equal this. So this part should go into the middle of the box, like this. But only put the first piece in to start with, because then we're looking for 2x times what would have given us 6x squared. Okay, because these two things get multiplied together to make this. So you just need to use some logic to figure out what times 2 is 6, well 3, and what times x will give us x squared, x. And then this gets multiplied by the 4 right here. And the next part that's a little tricky is that this diagonal needs to add up to 2x because that's what's in the middle here. And this is the hardest part of reversing the box method, is these two things had to have added up to 2 if this is the answer. So 12 plus what is going to give us 2? Negative 10x. So you're always going to try and make this diagonal equal whatever is in the middle up here. And then you're doing the same thing we did with that 3x of 1 times 2x is going to get us negative 10x. Well, 2 times negative 5 is negative 10. And x times, you don't need any other x's, it's already there. So it's just negative 5. And then you multiply that negative 5 times the 4. That makes a negative 20, which, hey, is the same number right there, which means that we don't have a remainder. If we did, this last number would be something other than negative 20. So our answer to this division problem is that spot on the top, 3x minus 5. Because if I were to multiply these two together, I would get that. That's what it means to divide something. Now you might be asking, why are we even dividing polynomials? Because polynomials can't really be factored, and so instead of following a factoring method, we can actually use division to help us factor. And that's what we're going to talk about on the back side. I'm going to go through 3 out of these 4 problems, and then I will flip to the back side for a second. I'm not going to do all 4 of these because I don't think the 4th one actually adds that much. I think it would be make more sense for you to rewatch these 3 than it would be to add a 4th one in there. So what you're going to do each time is start by taking whatever is on the bottom and writing it along the side of what's going to be our box. And then make that into a row. And we're going to add a column. We don't know how many columns we need yet, so just kind of leave it open. I know that's really uncomfortable, but we don't know how many we need yet. And then you're going to write the first term right here. And then you have to figure out, what do you multiply x by to get 2x squared? Well, you have to multiply it by 2, otherwise it wouldn't have the 2 in front. And to get from x to x squared, you need to multiply by an x. And then negative 2 times 2x is negative 4x. And we need to figure out how to make this diagonal add up to 1x. So after you find this number and you multiply it down, go to the next number, and that's what should end up being between these two. It doesn't get written directly in here because it's a combining like terms situation. So what do we add to negative 4x to get up to 1x? 5. Negative 4 plus 5 is 1. Then you're asking yourself, well, what do you multiply x by to get 5x? 5. X times 5 is 5x. And then negative 2 times 5 is negative 10. And I'm going to double check that up top to make sure it's the same number. So it checks out. There is no remainder on this one as well. So my answer is 2x plus 5. I usually like to write mine over here away from the table though, because otherwise I don't see my answer. You could always check your answer by taking your answer, 2x plus 5, and multiplying it by what you were dividing by. I'm not going to actually do that because guess what? If I were to do that, I would just end up making this table again. All right, let's move on to the next one, which looks a little bit scary because it's kind of long. I'm going to give you one hint here, and that is that you have to keep your eye out for zero placeholders. Because this problem skips a power. And what I mean by that is it has to go like this: x to the fourth, x to the third, x squared, x number. And this one goes straight from x squared to the number, it skips the x's in between. That's when you need to use a zero placeholder. So along the side of my table, I'm going to have x squared, 0x, and 1, which means I have 3 rows instead of 2 this time. You'll always be able to see the number of rows by writing this over here. Then you're going to drop this first term right here and figure out what you need to multiply x to the fourth by to get, or x squared by to get x to the fourth. Well, there's no numbers out front, so it's really just x squared, because then these two exponents add to equal 4. So if you're just focusing on exponents, they get added together when you're multiplying. So 2 plus what is 4? 2. And then be careful because this is technically x to the first. 0 x to the first times x squared is 0x to the third. You do want to have that power so that you keep your diagonals and your powers consistent. And then 1 times x squared is x squared. Then, for your next column, what you're going to do is focus on the x to the thirds. You want this to add up to 4x to the third. And you don't have any, you have 0, so that means all 4x to the thirds need to go right here. And then you need to ask yourself, x squared times what is 4x to the third? Well, you need the 4, and then to get from x squared to x to the third, you need an x. And then 0 times 4 is 0, x times x is x squared. 1 times 4x is 4x. And I do need an extra column because this should go all the way down to a whole number without any x's. So x squared, x, and then a regular number. So now I'm looking at my x squareds. I have one of them so far, and I need this to add up to 3. So if I have 1 and I'm trying to get up to 3, I need to add 2 x squareds, because 2 plus 1 is 3. So you're trying to get it to add up to these terms in the middle. And what do we multiply x squared by to get 2x squared? 2. And then you multiply that 2 going down. 2 times 0 is 0x. 2 times 1 is 2. And look, this adds up to 4x in the middle, like that. And this 2 matches that 2. So there's no remainder. The next one will have a remainder, and I'll show you what to do. So my answer for this one is the top. Right there. So this times this equals that. We're going to do one more and then flip to the back side. So we have x minus 7 on the bottom. So x minus 7. We're going to draw our columns in here. If you would like to draw the box all the way across like this, that is fine by me. Some people like to do that so that it has a border here, like that. So it's easier to see that the answer is the part that goes on top. So then x cubed is the first number that goes on the inside. And x times x squared is x to the third. X squared times -7 is -7x squared. And that's where we move on to the next column. And then this time, we want our x squareds to add up to -13. And -7 plus -6 is -13. And then x times what is -6x squared? -6x. -6 adds that in front, and the x multiplies by the x to make this x squared. And then don't freak out, this is going to be a little bit higher of a number. -7 times -6 is 42x. But this time we are wanting this diagonal to add up to 40x. 42 plus what will get us back down to 40? -2. So you just need these two numbers to add to what they're supposed to. And then x times what is -2x? -2. And that's when you know you're done, is when you get a number without an x at the end. So that means this is the end of my table. -2 times -7 is 14. But wait, that's not the same number as it is up here. So I have a remainder. And that remainder is -4 because I'm missing 4 parts. It's supposed to be 18 and it's actually 14. Here's what you do with that remainder. X squared minus 6x minus 2. That's the part from the top of my table. And then you add this remainder divided by whatever you were dividing by in the top. So x minus 7. And then we're going to do a couple on the back side and be done. All right, so how division helps us factor? The exact same way. So you're always going to end up factoring the numerator because whenever you divide it, if this is no remainder, then it's just these two multiplied. And over here, we're going to put a little comment that there can be no remainder. Otherwise, the problem lied to you and it's not a factor. I'm going to start with the one on the left, and if you want to stick around for the one on the right, go for it, but you don't have to. So we have 2x minus 3, 2x minus 3, and I'm going to draw my box. My first column, 2x times what is going to get us, sorry, forgot to write it. Write this first part right here. There we go. Now we're asking ourselves, 2x times what is going to get us 6x to the third, or 6x squared? That's 3x. 2 times 3 is 6. X times x is x squared. Then, -3 times 3x is -9x. So after you find a number on the top, multiply it down to fill in the other squares. And then we want our x's to add up to negative 11. So if I have negative 9, I need to add in negative 2x so that these two things add to negative 11. And 2x times negative 1 is negative 2x. Multiply that negative 1 all the way down, and we get 3. So this checks out. It's the same number it was up there. That finishes off my table with no remainder. Now, since there is no remainder, these two things multiply to this, just like they would have in the first lesson. So our answer is one factor, and whatever we were dividing by is the other one. Or you just write the two sides of the box in parentheses. But again, this only works if there's no remainder. All right, either stick around for the last one or go ahead and try your assignment. Actually, let's go ahead and just do one from the assignment together. There is one I want to talk about on the assignment, and it's number 2. So find your assignment, pull it up, and then watch this last one. The reason why I'm picking number 2 is because it looks kind of long. Because look how big the denominator is. X cubed, 2x squared, 8x, and 3. There are 1, 2, 3, 4 rows to this thing. Okay, and I'm going to start by putting my x to the 4th right here. So that's the first part of the top. X cubed times what is x to the 4th? Just x. And then you multiply that all the way down. All that's going to do is add a power. It's going to change this to x to the 3rd. It's going to change this to x squared. And it's going to add an x onto the 3. And then we're going to focus on our 2x to the 3rd. Figure out what needs to go here to make it negative 2x to the 3rd. Now, you can't multiply it. You have to add something to it. So how do we get from 2 to negative 2? If you're not sure, count it out on your hand. You start at 2 and you go to 1, 0, negative 1, negative 2. That's 4. And since we're going down, we're adding a negative. X to the 3rd times what is negative 4x to the 3rd? Negative 4. Now that we have a number without any x's, that's the end of our table. And then negative 4 times 2 is negative 8 x squared. Negative 4 times 8 is negative 32 x. And negative 4 times 3 is negative 12. Which, look, it ended in the same place. And actually what you can do is double check. These two add to 0 because there's no x squareds right here. 3 minus 32 is negative 29. So all of these diagonals still match up with the rest of it. You can kind of use that to check yourself a little bit. Okay, so my answer here is the top part, which is x minus 4.